Hello fellow hackers and greetings from Finland. This is Dr. Azure AD and unfortunately I couldn't make it this year. But no worries, I prepared a recorded session for you, my talk Hacking Azure AD Identities. Have fun!
Okay, so let's start. So very short introduction. So my name is Dr. Nestori Syynimaa. I work for Secureworks Counter Threat Unit, or CTU for short, as a senior principal security researcher, and you'll find me on Twitter or X, Mastodon, and also Blue Sky with the name Dr. Azure AD. And I'm also Microsoft's Most Valuable Professional, MVP, in security category, and also Microsoft's Most Valuable Researcher, third year in a row. And I think most of you know from my Azure AD or AADInternals toolkit. So it's an admin and hacking toolkit for Azure AD and Microsoft 365, and I'm going to use that today in demos. It's open source, you can get it from there. It's also listed in my attack as one of the software that group APT29, also known as Nobilium, has used earlier. So, contents. So first some background information or theory, and finally demos. So let's start by short recap that how the cloud actually works. Then an introduction to identities, a couple of attack scenarios, and then some semi-live demos, so how to attack these identities. So how does the cloud work? So here's the diagram. So we have a user on the left side who's using some clients. But what happens between those clients or what happens either when the user is using those? So we have the clients, and client can be pretty much anything from Outlook client to browser or even a PowerShell module. Then before you are able to actually use those services, you need to authenticate yourself. And in this case, you are authenticating using OpenID Connect and or auth. And basically when you authenticate, you provide a proof of identity, and as a return you will get a set of tokens, bearer tokens. So typically you have access token, ID token, and refresh token. And then when you have these tokens, then those applications can actually consume APIs provided by several service providers like Microsoft 365, for instance, or Azure AD itself. So when you call that API, you include that access token you got after authentication, and then you are able to consume that service. So yeah, it's simple as that. Okay, and second part, so we have some roles here. So for instance, Azure AD, or as it's nowadays known as Entra ID, that is identity provider. And that party knows about the client, Outlook or PowerShell or browser or whatever you are using, and also about the user what is told to it. So when you provide the proof of identity, you are also providing the information that what like a client you are using, so client ID, and who you are. There are different ways to prove that. And depending on that, the Azure AD might also know which device you are using. We will get back to that. And then we have the service providers, which can be Azure AD, it can be Azure, it can be Microsoft 365, it can be third-party apps. And this service provider is trusting the identity provider, which in this case is Azure AD or Entra ID. And again, it only knows about the client. It knows about the client and user, what the client tells it and also it only does what the client tells it to do. So for instance, if you are consuming Graph API, you may tell that, okay, I want to list my inbox. And then when the service provider gets that API call, it also verifies the access token. And that access token may have information. Well, it has information, but it may also contain information about the device. But all these are embedded in the bearer token. So there are a set of claims which are information about the user and or the device. And it also contains information that what authentication methods you used. So this is a very short recap how the cloud works. So your client is calling APIs and you are providing access tokens so that you are able to access those services. Okay, then an introduction to identities. What are identities? So Azure AD or Entra ID nowadays, you can think it as a container that has different objects. And Azure AD itself, it is representing the organization identity. So when we are talking about Azure AD tenant, so that is like an instance of Azure AD of certain organization. So anyways, the tenant represents the identity of a organization. Then we have user objects that are representing user identity. So they are like usernames and also which authentication methods the user has registered or is using. We have device objects. So when you are logging in using a proof of identity that includes the device identity, Azure AD then knows that, okay, you are using that particular device. And there's also information about whether the device is compliant. So if we have conditional access rules that are based on the compliance, it's based on that information. And then we also have the application ID, which actually is same as the client. So all the clients used like Outlook or Teams, they have their own client ID and also like all application object in Azure AD. And earlier I mentioned that when you are authenticating, you are using OpenID Connect and or OAuth or Open Authentication. And here's some terminology related to that. So we have the identity provider, Azure AD, which in OAuth terminology is authorization server. Then we have the service providers, and OAuth calls them resource server. And then the user, which can be either member or guest. They are resource owners. And finally, the application is OAuth client. And we see a kind of a graph, how this works. It looks like this. So the authorization flow. So in the first step, the resource owner is using the client. And if that's like Outlook client, for instance, it kind of tells the client that, hey, I want to access, let's say, my inbox. And then in step 2, the client is making authentication it's making a request to access the resource. In this case, it's saying that, hey, I want to use Graph API, and I want the scope to be like I want to read all email, and I'm using this client ID. And then there might be there is actually like some authentication method. So whatever it is, it depends how the flow goes, but basically it might be as simple as username and password, or it might require MFA, or it might be some certificate-based proof of identity. But anyways, after the authentication, the authorization server is returning a bearer token. And then the client will access the resource server using that bearer token. And that's it. So quite simple flow. But it's all about identities and access tokens, pretty much, like in how the cloud works a couple of slides earlier. Okay, now I mentioned the bearer tokens. So which kind of bearer tokens they are actually? So we have well, usually when you authenticate, like here that you want to access, let's say, Graph API using Outlook client, and you proof of identity. You provide proof of identity. To Azure AD, it will return you typically 3 different kind of tokens. And the first one is ID token, which tells who you are. Nothing more, nothing less. Then we have the access token, which tells who you are, but also that which services you can access using this access token. And finally, we have refresh token. And the first 2 ones, they are valid about 1 hour. And then we have the refresh token, which is used to get a new access token if they are like if the lifetime of those are passed. So when they are invalidated. And that is valid for 90 days. And a refresh token can be revoked. Access token or ID token you can't revoke, which means that if somebody is able to, let's say, steal your refresh token and is able to get a new access token, and even though you are able to revoke the refresh token, which means it doesn't work anymore, the access token still works as long as it's valid. So one thing to remember. And then what is inside the access token? So here's an example. So it's quite typical access token. So there are not all claims there, but the most important ones. So first of all, we have the audience, which maps to the resource server, which in this case it's outlook.office365.com, but it could be like graph.microsoft.com or graph.windows.net for the, well, almost deprecated AD graph, and so on. Then we have the issuer, which is the authorization server in OAuth terminology. And in this case, as we can see, it's a certain tenant, Azure AD tenant or ID tenant. And finally, we have the scope. And the old clients, if you will, they are using this weird scope like user underscore impersonation, which means that this particular token can do everything as that user can do in that resource. But nowadays they are usually like mail.read.all, which means that even though the user could do other things in that service, with this access token it can only read email, so it can send email and so on. So nowadays they are more restrictive. And then finally the proof of identity. So there are different ways to prove your identity. So the first one is username and password, or also known as ROPC or resource owner password credentials, which is the typical one. So if you want to prove who you are, you may log in using username and password, and also you can use, and sometimes you can use those for applications. You can use Authenticator, you can use FIDO2 keys, you can use Kerberos tickets if you are using single sign-on. You may use SAML tokens if you are using private identity. And you may also use primary refresh tokens. We will come back to those in a minute. Refresh tokens, Windows Hello for Business, certificate for user if you are using certificate-based access. For device, each device has a certificate that are representing that device. And then we have the application, which also can use certificates. And I think the latest one, or this is the latest one, is the temporary access pass or TAP, which you can provide to user, which Well, actually, it doesn't, by definition, can be used to prove your identity, but it can be used as a MFA, so or multi-factor authentication method. So if you don't MFA, you are required to use one. Admin may create you a tab so that you can use that to get access token. And then using the access token, you can register new devices and so on. And from all these, I could say that the PRT is the most powerful one because it proves who you are. It also proves which device you are using. And it also typically includes MFA claim, which means that you can use that for any service that is requiring MFA. Well, there are nowadays you can twist them so that you might require that you need to use phishing resistant MFA to be able to access services. Okay, so attack scenarios. So what kind of things that you can do? So identities. So first one is that you can steal the proof of identity. And the first one is quite often used, which is called phishing. So you may use things like man in the middle, also known as adversary in the middle, where you are creating a service using a URL that is similar to login.microsoftonline.com. So you change a couple of letters or something and you somehow lure the user to that page. And then it's like just proxying stuff to real login.microsoftonline.com. And to user, it seems that you are actually logging in. And you might be even asked to provide MFA, like using the authenticator app in your phone. And then you will get the access token. And the other thing is that you can use device codes flow for phishing. So you lure user to provide device code. And when they are using a device code to log in, and then they use whatever authentication method they are using, you will get also an access token again. And well, actually I didn't include here, but the easiest way to do this is that you just try to get users username and password, or you can buy them. So if there's nothing else like MFA or that kind of things in place, that's the easiest way. But nowadays, when you have, so these are the phishing methods that are still working nowadays. And then another thing is that you can steal tokens. So if you have a browser, just with the user, user credentials, you can steal it from the browser, or if you are able to access user's computer, not just browser but the whole computer, there's a lot of tokens lying out there in various cache files, for instance. And finally, you might even steal users' PRT. So not just the token, but the real PRT and also the session key that is required to use those two. But yeah, that's the details are maybe another story. And then we can spoof the proof of identity. So SAML tokens, so call to SAML attacks, the Solarigate attack, if you will. So basically, in that attack, you need to get access to the computer. That is, well, typically it's ADFS server or Azure, Active Directory Federation Services. So if you're able to compromise one of those servers, you are able to export the token signing certificates, and then you can offline, you can create a new SAML tokens. So you can really spoof any identity of the tenant. And the best part here is that you can actually bypass MFA also, just by adding the claim to that SAML which says that I already did MFA. And then Second one is a Kerberos ticket. So if you are running service called seamless single sign-on, or you are using that is based on Kerberos. So if you are able to compromise your on-prem AD, you can get the NG hash of the service account that is used for querying these, and then you can again create Kerberos tickets and exchange those to access tokens. This doesn't bypass MFA though, so if you have MFA, you can block those. Then we have device certificates, which means that if you are able to compromise a computer that it has already joined, for instance, you can export those certificates from there. And using device certificate and transport, what is that? Transport key? I think it's transport key. So with those two, you can actually spoof the identity of the device. So you have username and password, you have the device certificate and transport key. With those three things, you can request a PRT from Azure AD, and then the PRT contains the device claim. So again, so let's imagine that you have a situation where you have a computer that is domain joined and it's compliant. It's a Windows machine, for instance. You can get, if you can export this certificate and the transport key and then take them offline, let's say onto your Mac, you can just, call Azure AD and provide, with these you can provide the required information, then you will get back a PRT, and with that PRT you can, get access tokens. And from Azure AD point of view, it seems that even though that you are running that in your, let's say, Mac, from Azure AD point of view, you are still using that origin device because you prove the identity of server or computer using those certificates. Then if you have a certificate-based authentication, if you are able to compromise the certificate authority, you can again spoof identities. So you just need to create a certificate that has the matching like common name or whatever you have configured, and then you can be that person. And also this can be used like for like single factor and multi-factor authentication, so it depends how you configure that. And the bad thing here is that you can't actually revoke certificates. So Azure AD doesn't require that you use certificate revocation list. So if you're not using that, you really can't revoke certificates. And then finally, we have the pass authentication, which is actually quite neat. So technically, I think this is, well, kind of it's spoofing proof of identity. At least you can use that to steal one. So basically, if you're able to compromise the server that is running pass authentication agent, you can export its certificate. You can take that certificate again offline, and you can build a tool that is then impersonating that agent, which means that you can connect to Azure AD and tell them, hey, I'm that agent, and then Azure AD is sending you authentication requests, and they are encrypted, but you can decrypt them using that certificate, and then you can respond that, okay, credentials were correct, even though they weren't. So this kind of way you can spoof who you are. So you can make PTA to accept all passwords, regardless are they correct or not. Okay, and I kind of categorize these in these things. So first of all, we have the cloud. So we can do the phishing there, of course. And in the middle, adversary in the middle, you can register device certificates. On-prem, you have the identification, seamless single sign-on, certificate-based authentication, and pass authentication. And in Endpoint, you have token theft, and there are various things that you can actually steal from there. Okay, and now it's a demo time. So let's start by showing you a little bit that what kind of environment I have here. So I have a contoso here. So quite often used tenant name, and then we have registered one domain, wildwesthackinfest.azurelabs.online. I have a couple of users here, but let's go to security. Just going to show that I have some conditional access policies here. So I'm enforcing MFA, and then I'm going to require phishing resistant MFA for Office, for instance. And then to those users, so I have 2 users here, which I'm using in my demo. So there's me. And I don't have any devices. Nope, I have some authentication methods. No, I don't actually have any. And then we had another user, my colleague, Juuso Santalo, who I'm using as an example here. So he has a device. So it's Microsoft Entra joined. And he also has some authentication methods. So he has a Windows Hello for Business, and then he has a software or auth token for MFA. Okay, so let's fire up a PowerShell. So I'm using PowerShell, I think this is 7.8 or something. And I start by importing Azure AADInternals. Oh, that was actually quite quick, and I'm using version 0.9.2. And let's start. So first I'm gonna save credentials. So my name here, wildwesthackinfest.azurelabs.online. Say the password like this, and then just try to get an access token. So get AAD access token for, let's say, AD graph. Save it to cars. Provide credentials like this. And it says no, we can't do it because you need to enroll to MFA. So right here to do that. Okay, so let's try to do that. So let's try to get access token for my sign-ins. But it says the same because I need to have MFA. So how to proceed? So let's imagine that we have been able to fish somehow user's username and password like we did here, but because MFA is required, we can't do anything here. Typically, it's when they are starting to do the MFA, it's not necessarily required, but it's like that you need to register that. And actually, I could do this now with the browser, but I haven't implemented that here. So we're gonna, well, we need to do something else. So actually, I'm gonna go here, find myself from here, and I'm gonna ask a admin that, hey, could you give me a tab so that I can, well, do something like register my MFA. And here are some parameters which are important. So usually it's not one-time use. It would be much more safe if it would, because you can use this in an MFA method. So for instance, if we have like 1 hour time here and it's not one-time use, I can use it multiple times. So also if you are able to get that tab, then you can use that as an MFA the whole time it's valid, but it can be no now. So let's just add it. I'm just gonna copy this and go back here, and I'm gonna save that. I'm gonna get it from the clipboard. Let's see, is it okay? It is. So now when I go to my sign-ins, I'm gonna provide tab and that variable name. It is now doing the MFA using tab automatically, like this. Also, we could do that without providing this, because now it knows that I have a password and tab, so I could choose password, but well, it won't accept the password. But if I use tab, it will ask the tab button. But let's do it like this way. Okay, so now we have access token. So get AADInt cache to prove that. So we have access token to here, which is the my sign-ins, and then we have one for graph, AAD graph. So now we can register a new device. So new register AADInt MFA app, type equals OTP, device name can be my device, and that should do it. No, it didn't. Okay, so let's try to do that again using a previous version of version 5 of PowerShell, because there are still some things that doesn't work well with the latest PowerShell version, but it should work, but it seems that it doesn't. So let's do it again here. So we import a module. Gonna save the query equals get cancel. Hacking fest. Okay, so get AADInt access token for my sign-ins, for the credentials and the tab. Like this. Oh, safety cars. Okay, so let's now register AADInt MFA app, OTP. No, the type, OTP, device name, my device, like this. Okay, and we have the secret key right here. So let's just copy that. So OTP equals this. Okay, so now we can see that we have those like MFA method. Sorry, two access tokens both have the tab and MFA. So that way, when you're consuming those services, they know that you have authenticated using tab or MFA. Okay, so and MFA. So whenever MFA required, you can use those. Now just clear the cache, and then I'm gonna get a new one. Let's see, for AD join. So now I'm gonna join a device. gonna provide credentials like this, and then also I'm gonna provide the OTP secret key, OTP, and I'm gonna save it to cache. Like this, and just do it. So ask that am I going to use the tab or password, because Azure AD internals knows which method you have available, and we're going to use password. And then because I provided OTP secret key, AD internals is able to do the MFA for you. So get AD int cache shows that we actually did MFA and used username and password. Okay, so I have now the MFA, but if I want to use, let's say, like Teams, for instance, I'm going to use the password again. I did MFA, but it says that we have conditional access that blocks that. So we should have like a device resistant method to do that. Now, if the user is allowed to join devices, you can actually get one of those. And one of those methods is Windows Hello for Business. And this actually is based on research of Dirk Mollema. So thank you for this. And you can thank him also. So let's start by registering a device. So say join AAD device to Azure AD, provide the join type, which would be join, to provide device name. I can say my fake device. Device type, we can say this is Windows. We can even provide OS version if we want to, like 12.1. Not sure if there's ever going to be one. And that should do it. So now as a user, I registered a device. So what happened? So there we added an object to Azure AD, but we also created a certificate, 9A, 2F, and so on. It's right there. So it's same as the ID of the device. So when I go here, I should see my fake device here. And we can see the object ID of the device is, device ID is that. So object ID is a different part. It's Windows 12.1. Okay, so the first step is that we need to get a PRT. And we can do that by saying PRT keys equals new AAD and PRT. Oh, get AAD into user PRT keys. We're going to provide the certificate. In this case, it's what we have here. And that should do it. So now it asks me to log in. Again, we're going to use the password. And I need to do MFA, so I'm going to do that. Phone app OTP, why didn't I provide that? Okay, so let's do that again. OTP. Oh, okay, I actually can't do that, so I need to do that in a traditional way. So password like like this. Use the phone app OTP. And I'm gonna go here. Need to provide the correct secret key, which is in somewhere here. So it's that one right there. Just gonna copy that. So AADInternals have it can calculate the OTP. So need to do it in the second window. Copy it to clipboard. Then go back to here and I can just paste it. So now I logged in with MFA, and it gave me all the material I need for, well, it gave me the PRT actually. So if I type PRT keys, what we see here is that the refresh token is the PRT and the session key is the one that the proof of possession key. And we know we need those tools to get the PRT token that we can then send to Azure AD. So this is like with this information, we can create those PRT tokens. So next step is that I'm gonna the PRT token equals new AAD int user PRT token. Gonna provide the settings. And PRT keys like this. And now we have the PRT token. So next I'm gonna say set AAD int device Windows Hello for business key. And I'm gonna provide the file where that is already. So I'm gonna use the same certificate as I used for device, so it's just easier. Like this. Oh, sorry, I need to first do something else. So get AAD in access token for Windows Hello for business. Use the PRT token. I'm gonna save it to cache. Okay, I need to I need to log in again because it requires that I have a certain kind of MFA. And it wants me to do the MFA again. It's here and then here and back, and that should do it. Okay, so now I can say that set AAD int device Windows Hello for business key. I'm going to use the existing PFX file, and then that did it. So now if I go back here, I'm going to go to authentication methods. So now you can see that I have Windows Hello for business key. Even though I don't have any Windows method whatsoever, I just registered those things, and I was able to do that using the OTP. So I didn't need to have anything like phishing resistant ones, not yet. Okay. Okay, so what can I now do with that Windows Hello for business stuff I have? Well, let's see. So we can see what's the device ID, we can see what is the key ID, and because I use the same certificate I used for device key, that's easier for me now to get like new things. So first let's start by clear AAD int cache. No, let's do it first at get. Like this. And we can see that this one here, I had to do like to get that Windows Hello for Business key. So I had to do the MFA once again. So that's the NGC. So that's next generation something. Can't remember. Next generation cryptography. Yeah, so I think it's that. But anyways, let's just clear this. Clear AAD into cache. And let's try to get a. Okay, so now that we have Windows Hello for Business key registered, we can now ask primary refresh tokens using that. So let's start by doing that. So PRT keys equals get AAD user PRT keys. Provide the certificate file for the device certificate, and then I'm gonna say that use device cert for Windows Hello for Business, and that should do it. Oh, username, or I can just say cred.username. And now I have a new set of keys, so I didn't need to use password because I'm using the Windows Hello for Business key. And now the new keys are saved there. And I think they are also here. So now I can say PRT token equals new AAD user PRT token. Provide the settings, PRT keys, and now we have the PRT token. And with that, we can say get AAD int access token for Teams. Provide the PRT token. And now we have the access token. Let's just save it to cache and so we can see what we have. Yes, so now we can see that we have an access token. And because we were using the Windows Hello for Business key, which is a phishing resistant one, we were able to get that access token. And here we can see auth methods RSA, which means that we use the Windows Hello for Business key to do this. And we also got an MFA. So that was kind of a neat way that if you have a user, you have a method to add a device, and if you have like an access to lower level of MFA, by this way you can actually register there a new Windows Hello for Business key and use that as a phishing resistant MFA method. Okay, so that was kind of what you can do the cloud way, so you can register stuff and so on. Device, and then using that device identity, you can add that key, Windows Hello for Business key for that device. Okay, so this time we have no time to cover those on-prem stuff, but I'm going to show you some endpoint stuff anyway. So, okay, so next, here's a desktop. This is Joshua's desktop. Let's imagine that I was able to get his username and password somehow. Now I'm able to log into his computer locally. And then let's see what we can hear. So let's start by starting PowerShell. Or actually 2. So just one as a regular user, one as an admin. So let's start as a regular user. So I'll say PRT token equals get AAD user PR. Oh, I need to, okay. Module AADInternals first. Do that to the other one too. So yeah, I can say PRT token get AAD into user PRT token like this, and now it asks from Windows, hey, could you give me a PRT token? Let's see, can we get an access token for that? AD graph, gonna provide PRT token. That didn't work for some reason. Don't know why, but okay, but it doesn't matter. The point here is that you can get an PRT token from a local user just by logging in. Now, why it didn't work? Well, there might be various reasons for that, but anyways, I show you so that you can actually do that. Okay, the next one is that I'm gonna go to Hacker. Yes. So let's just delete that. So what we can do here is that we can export the device certificate. Local device certificate. Except that it didn't work. And transport key, well, that did. So there might be some in this new version I'm not aware of, but anyways, technically you can do that. And then with those, you can get those offline and you can go and get a PRT token. You need to have, of course, username and password so that you can prove who you are. But with these, you can then prove that who the device are. So you can actually steal the device identity. Now, what is even more fun is that if you know the username and user's password, like in this way, and this computer is using Windows Hello for Business and is also registered as a key to Azure AD, you can get the PRT and session key with just username and password. So if we say that credential equals get credential like this, oh, sorry. Say that PRT keys equal get AD into user PRT keys. The Cloud AP can provide credentials like this, and then we took them. So they are in Cloud AP cache, and there you can actually get the token and then the session key. And with those, you can then you can get them offline. You can request a PRT token, or you can create PRT token, and with the PRT token, you can get access token, and those fulfill that phishing resistant stuff. But anyways, I think we are running out of time, so thanks for having me, and if you have any questions, you can reach me out in Twitter or email or LinkedIn. Thank you, and have a nice hacking conference.